Hello, everyone, and welcome to our next keynote session today on how hydrogen fuel cells could be the lowest cost solution for zero emissions transit. I'm happy to invite here today to share his insight, Rob Campbell, Chief Commercial Officer for Ballard Power Systems. And as many of you might know, CUTRIC's worked with Ballard for several years now. We've been trying to get hydrogen fuel cell buses out the door. And in the words of Parvati Pillai, who's our project manager on research, it's about a hydrogen homecoming. We've been a world leader in hydrogen technology innovation for years. We had the BC Whistler trial now over 10 years ago as a real Olympic demonstration. And yet today still there are zero hydrogen fuel cell buses out the door on Canadian roads. And that's something CUTRIC is dedicated to fixing and overcoming. Lots of potential in this industry, lots of potential for zero emissions, lots of potential for GHG savings, operational savings, and helping cities get back on their feet. So with that, I'm going to turn over to Rob for his great insights, and then we'll turn to questions from the audience, and I have no doubt we'll have a plethora of them. Welcome, Rob.
Thank you, Josefa. It's great to be able to virtually present to you today, showing our overall resiliency to challenges such as COVID-19. Thanks to CUTRIC for being so innovative and carrying on with the conference. I actually was looking very forward to visiting Winnipeg, as I have fond memories of Winnipeg, learning how to play hockey there and how to swim. Two great Canadian pastimes, and hopefully we can all travel soon and I can make that trip to Winnipeg. I'm really excited to present our vision for hydrogen-fueled buses as the lowest cost solution for zero-emission transit. This is the outcome of years, if not decades, of dedicated work by our industry to bring affordable solutions to eliminate emissions. Many of the leading companies in this field are right here in Canada. So Canada, yet again, is a leading technology innovator, and it's great to go down memory lane, and we hope to see those hydrogen buses in Canada soon again. The good news is that I have to report is that our industry is delivering fuel cell buses. Hundreds, if not thousands of them are now being delivered across the world in ever increasing numbers. And fuel cell buses are the clear adoption trend for this decade. Now, in terms of my own background, I've been in clean energy for almost 20 years. And I'll do my best to show you how real, how ready we are to being able to move forward with zero-emission transit fueled by hydrogen. First, a few words about Ballard. Now, Ballard has been in business for 40 plus years. Last year was our 40th anniversary. And throughout this period, we have pioneered zero-emission technology. In fact, the world's first fuel cell bus was powered by Ballard over a quarter of a century ago. So Ballard and fuel cell buses go way back. We've matured our technology since then and are now in our 8th generation of products. We're busy scaling our manufacturing, we're expanding our markets and growing worldwide. So we have a robust future ahead of us. We are ready to help public transit fully convert to zero emissions, and we believe this can happen this decade. Ballard has the experience, know-how, technology, and the team to make this happen. So in terms of our vision, it's in less than 10 years, fuel cell buses will become lower cost than any alternatives. And this is an outcome of a report that we issued before the chaos of COVID back in January. And it was a joint report done by Deloitte to get the macro analysis done and the worldwide view of the industry. But it's absolutely the case. And to reinforce that, there was also a follow-up report done by McKinsey for the Hydrogen Council. And it basically had the same information that fuel cell powered buses, fuel cell powered vehicles will be the lowest cost solution for the market. And both of these reports are available on our website. But you may ask, how can this be the case? Well, this is all about convergence of 6 key enabling factors that are making what we call the hydrogen economy truly transformative for our society going forward. So let's have a look at these factors. In brief, we have technology. the outcome of decades of work, as mentioned, with the support from the Canadian government as well. Performance, millions of kilometers of road experience with feedback from customers, continuous improvement to ensure proven, robust, and reliable benefits. Infrastructure, large fueling stations needed by public transit are more affordable and easier to adopt with hydrogen. Industrialization, massive investments are now occurring worldwide to scale both fuel cells and hydrogen production. It seems that this is almost a daily news update with even billion-plus-dollar projects being announced, as recently the case with support in Germany and some major project activity in Australia. Fuel. Sustainable and affordable hydrogen can be produced from renewable energy, making it zero emission, which is like very good news. And finally, the environment. We are working to ensure minimal carbon footprint, maximum recyclability, and maximum reuse of materials to give the best overall value proposition by moving towards hydrogen. Let's go deeper. First, let's touch on technology. At a high level, fuel cells are combined with batteries in the powertrain. They work together synergistically, with the battery providing instantaneous power and the fuel cell the overall energy needed in the form of electricity. Therefore, the overall electrification of the powertrain that has occurred over the last decade has brought forward all the complementary systems needed for the effective use of fuel cells. Combine this with the parallel maturity of fuel cells, and we now have fuel cell buses being manufactured in 3 continents by multiple OEMs. We are on our way. And when it comes to performance, there are clear advantages with fuel cell buses. Superior range. New Flyer announced that the buses delivered to Orange County in California have full load range of 550 kilometers. We heard yesterday from Mr. Cliff Thorne of Orange County that fuel cell buses fully meet all of their operational needs. And we look at fuel economy, especially in the Canadian context where we have our classic cold Canadian winters. The heating benefits of fuel cells really help increase the overall fuel efficiency, while at the same time, no compromise to passenger capacity due to the lower weight of the overall systems and rapid refueling, similar to the time taken for CNG. Operators can effectively treat these buses the same way they do today with their diesel-powered equivalents. One-for-one equivalency to seamlessly integrate into existing operations. When we talk about the need to move fast with zero emission, does this sound appealing? Absolutely. Now let's think holistically about the complete ecosystem and what's needed specifically, around fueling. And this is all about the impact of refueling with molecules, hydrogen molecules, compared to charging with electrons through a variety of electrical charging systems. And hydrogen refueling is more cost effective as it scales. And this is one of the reasons we believe that it's advantageous to deploy fuel cell technology at public transit, where you fuel in the depot and you fuel larger fleets, typically more than 50 buses. And this is the sweet spot for hydrogen infrastructure. If you look at the graph, it's roughly 50 to 100 buses. There are clear advantages when we think of hydrogen. A variety of options exist to enable space-efficient integration of the fueling systems onto the existing transit properties. To put in perspective, more fueling can be done by simply having more hydrogen storage on site or more frequent hydrogen deliveries in comparison to having larger and larger charging capacity to accommodate larger fleets. The hydrogen can also increase resiliency in the event of power outages. Now, we talk about industrialization. This is all about scaling of our industry, and volume production is now underway with a highly energized supply chain. The impact is a massive 70% reduction in cost this decade, as forecast by McKinsey. We have also verified this forecast with our own internal analysis and ongoing cost reduction activities. This will tip the balance in favor of hydrogen as the solution of choice. I'd like to touch upon how we can tie this in with renewable energy and carbon capture to truly unlock the potential here in Canada. With cumulative demand across, sorry, just got tied up here, there's a larger benefit we need to consider of using hydrogen, and this is the ability of hydrogen to effectively couple both renewable energy and legacy energy assets in our economy. We call this sector coupling, and our vision is that hydrogen can be used in multiple sectors ranging from transportation to industry to commercial and residential heating, thereby enabling significant scaling of the hydrogen supply system. Further, hydrogen can be used for cost-effective, large-scale energy storage. Why is this significant? Well, with the cumulative demand across multiple sectors and cost-effective energy storage with hydrogen, we can embark on a huge long-term expansion of renewable energy generation that will ultimately allow us to keep our planet at a safe temperature. Canada already leads in hydropower, and a good example of that is Manitoba Hydro, which literally has 100% of its electricity produced by renewable energy. Let's put our strengths to work. Also, recent reports concerning COVID-19 have highlighted that air pollution and COVID-19 are linked to higher fatalities. We definitely need to accelerate our efforts to also address air pollution in our cities. Now further, the cost of the hydrogen, as indicated here, will plummet to $1 to $2 per kilogram. These values represent the most affordable zero-emission fuel possible. Is this a dream? Absolutely not. Is it compelling? Absolutely the case. Consider this. Renewable energy is already the lowest cost electricity being produced on the planet, with multiple examples of public tenders where this renewable energy is in fact less than 2 cents a kilowatt hour. And this is the key driver that will lead us to be able to produce affordable hydrogen. We just need to harness that large scale hydrogen storage solution in order to fully capture this already existing opportunity. And again, Canada has the opportunity to lead in this area. Finally, when we look at emissions and greenhouse gases, fuel cells are truly attractive when it comes to sustainability, with being some 75% superior in terms of cradle to gate greenhouse gas emissions, and also enabling very high recyclability within the platinum industry, which is the main catalyst within our product. The platinum industry is already geared to recycling. For example, we fully recycle all of our core membrane electrode assemblies, or MEAs, which is the basic cell or building block of the fuel cell stack. We also reuse all of our bipolar plates when we refurbish these stacks for reuse. Now you can see why I am so excited about fuel cell electric buses for all of us. The solution is proven, it's affordable, it's sustainable, and delivers to all of your transportation needs. Let us show you how we can do it. We're ready to help. Let's transform our industry to 100% zero emission this decade. Thank you.
Much, Rob. That was really quite helpful in terms of providing an overview, and we've already got a load of questions coming in. So we're going to kick off right on one of the points you ended on, and we're often asked this about cradle to grave, or as you said, cradle to gate. In terms of emissions overall from the production side, can you help folks understand from a hydrogen fuel cell electric bus perspective? You know, in Europe, we're hearing that it's much more hydrogen fuel cell driven, whereas in North America, the design is much more battery driven with the fuel cell stack as a generator. So when when we look at the emissions for producing the powertrain, is it that not only is the fuel cell stack more recyclable or fewer component parts, but the battery is a lot smaller on board than you would have, say, in a 600 kilowatt hour battery pack of a battery electric bus? Is that part of what's going into the powertrain, makes fewer emissions to actually innovate, even though it has a battery on it as well?
Absolutely. You're absolutely correct there. Just for an example, we have like an average 40-foot bus in Europe uses less than 30 kilowatt hours of batteries in combination with the fuel cell system. So immediately you're taking a fraction of the batteries. Effectively, you're just using those batteries for the rapid response. And in fact, our first buses in Europe, in London, used ultra capacitors. They didn't even use batteries, but batteries now are a great solution. And by minimizing their use, but maximizing the benefit of the battery technology, we have a win-win situation.
So that goes into that.
Also, the basic materials we use in the fuel cells are your regular materials, not that exotic, except for the use of the platinum, which we recycle.
Mm-hmm. Yeah, I think that's very helpful because we've been advocating for folks to understand that hydrogen fuel cell electric buses are electric vehicles. They're not like some other beast out there, but they've got this range extender. And so clarifying that point about they are battery electric vehicles, but at the same time, their battery's a lot smaller, really helps to contextualize the situation. So towards that, then, a series of questions have come up from the audience, and I'll ask two in one, and it's from Aaron Cook out in Winnipeg. What efforts is Ballard making to support the development of hydrogen infrastructure needed to support the buses? So how much are you involved in that entire supply chain and helping to develop that? And then allied to that is, how do you recommend going about communicating this to the community to avoid NIMBYism, and basically approaching the conversation about hydrogen safety when and if these electrolyzers and hydrogen production facilities need to be built in residential areas? So what's the communication mechanism, and what is the role of Ballard in helping to develop that hydrogen infrastructure?
Yeah, great questions. And thank you, Aaron. And sorry we weren't able to get to Winnipeg to see you. But overall, on the first one, I think this came up in some of the sessions earlier, is you have to look holistically. You have to look at your fleet, the longer term plan for adoption, and you have to think of the infrastructure with the technology together. And how this is working out well and accelerating in other markets is the projects are of critical size. We started off with a number of projects in the 1 to 5 bus range, which is, I think, very similar to the experience with the electric buses. That's more challenging with fuel cells because there's a critical mass you need to invest in order to get the hydrogen infrastructure in place. So one of the key recommendations is you have to look at not just tomorrow, but longer term. And again, I look at Orange County, where they have scalable infrastructure that can go up to 100 buses, even though they're starting with 20 buses. So that was really good planning on their part to facilitate that. What is Ballard doing in terms of facilitating infrastructure discussions is we're promoting the idea of like a cluster approach where you can go after fleets of vehicles, public transit, trucks, other systems, and we're forming consortiums to make this happen. We're a member of a consortium in Europe, and we're in discussion in multiple areas where it's all the same thing. We need to come to the table and make it simple for the customer in terms of bringing all the pieces of the puzzle together: affordable fuel, the vehicle option with our OEM partners, and then the follow-on support and service to make sure that those vehicles are well maintained and operating to the satisfaction of the customer. So we recognize we can't just be out waving the flag for fuel cells. We have to wave the flag for the industry. And this is a great opportunity because when we step back and look at the industry, it truly is the opportunity for Canada to transform itself towards that zero emission economy faster and more effectively, because we have all the ingredients right here. We have the technology, we have the renewable energy resources, and I think publicly we have the will. From a safety perspective, hydrogen has a great safety record. And again, there needs to be that learning curve. We have to fully respect the need to disseminate information And this is where working with CUTRIC and the Hydrogen Association for Canada, as well as other entities, we can get that message out because it's a great message.
It's a fantastic message to end on, and I'm only sorry we ran out of time because we had some questions about whether CNG is preparing some systems a little bit better to shift to hydrogen. Hopefully we can come back to that. And I invite folks, if you didn't get your question answered, if you can join in the networking, we might be able to lure Rob into some of the networking at the end of the day to get some of those questions answered. But thanks so much, Rob. In this era when we're all trying to help the government figure out where green economic stimulus dollars should go, there is no doubt that there's a hydrogen economy and a supply chain that could really employ a lot of people in this sector. So thanks so much for your insights, and thanks for the leadership that Ballard's provided for over 20 years. Thank you very much to you and your time, and thanks to everybody attending. We look forward to joining you in the next session starting momentarily.
Thank you. Thank you.